Welcome back. We're taking a look at 2.3 still, now dealing with polynomials when we're trying to find the zeros. So previously we had polynomials that were already factored, which was nice. That was really enjoyable. That was really convenient too. But now we have to actually hunt these down. And so the goals that I've set out here are a good step-by-step procedure that we should aim for, where we want to get our function pretty much set equal to 0. So we'll do just that. We have all of our terms on the same side, so this is now fair game. And we're setting this equal to 0. We're then going to try and factor as much as possible. So think back, way back, when we were dealing with factoring, what kind of factoring could we work with here if we have 4 terms? Play some hangman real quick. It's a way of factoring. It's not diamond method. You should go think about this with grouping. So we're going to factor this by grouping, which says that we look at the first 2 terms, factor out what's common, which in this case is x squared. We rewrite the next 2 terms. So it's again as if we're blocking out the other 2 terms, just focusing on the greatest common factor with these 2 terms, which was x squared. We rewrite the rest of it. We know that if we're confident and we did this correctly, this binomial seen here, I'll show this in red, this should appear again over here when we take the greatest common factor for the next 2 terms. So this also has to be x plus 3. The greatest common factor that would have to work in this case is negative 16. So negative 16 would be the greatest common factor for these 2 terms here, negative 16x and negative 48. So we'll take that out. We can then rewrite this as x squared minus 16 x plus 3 equals 0. Can you factor any further? X plus 3 is pretty broken down, but what about x squared minus 16? This should be pretty easy difference of squares to spot. So square root of 16 is going to be 4. We can rewrite this as x plus 4, x minus 4, where this has x plus 3 still hanging out. We got these 2 again because this top part here could be factored further. And so now that we've factored as much as possible, we're checking for solutions using the zero product property, which says that if we have terms here multiplying and it equals 0, the first factor could be equal to 0, second factor could be equal to 0, third factor could be equal to 0. So if you set up the 3 one-step equations, you can do that. It's basic algebra 1, but I'll jump ahead and say that x could be equal to negative 4, positive 4, negative 3. These are our zeros. So we have 3 of them. If you're not convinced, you can try to graph these out, and we'll do just that. We see that when we graph out this function, x cubed plus 3x squared minus 16x minus 48, we have zeros just where we expected. Negative 4, negative 3, positive 4, we're done. That's all that was asked with the problem. We also see the end behavior has this falling to the left but rising to the right, and we'll see that come back again in the next section, next problem, when we tie all of these things together that we've seen so far. So now that we're graphing, although Desmos is nice, a lot of the properties that we've discussed in this section come back again. So leading coefficient test, if we look at this, we have x cubed. Since our coefficient is 1 and our exponent is even, this is going to definitely fall to the left. I'll actually write it down here. So we have our characteristics. Definitely we're falling left. we're rising right. So we can already start to sketch out what this looks like even if we don't have points necessarily. So probably looks something like that. We can get zeros if we factor out whatever we can. So if we factor out x, because x is common with all of these, this leaves us with x squared minus 4x plus 4. We can factor this further using diamond method to x, and then x minus 2, x minus 2. You might notice that x minus 2 is appearing twice, so building off of multiplicity, which was a crucial part here in the steps, we could rewrite this to x and then x minus 2 being squared. Based off of this, we have some zeros. So we can say that there's a 0 where x is 0, and it's going to cut through. So this passes through the x-axis. Again, because it's multiplicity of 1. We also have x's where x equals 2, but this is going to be a turnaround. So this is going to hit and turn around. And so I think it's nice to just list off your characteristics before you even graph anything. Notice we've done a lot of work just based off of graphing what we've seen here. So if you graph out an XY plane, definitely encourage you to use graph paper on this just to get familiar. We have a 0 at 0. Just so happens to be our y-intercept. I'll mark up some points here too. So I know that when x is 0, the outcome is 0. When x is 2, the outcome is 0. So I know that this is going to fall to the left, so this is going to be kicking back in from here. I know that my next 0 is 2, so I want to make sure that I hit here. So have this kind of go up, swing back. And I know that if this hits when x is 2, it's going to have to swing back. So I know that this goes up, this goes over, and then it's going to keep on going up and to the right. You could also say that if x equals 1, the outcome is 1. This is a pretty easy point you could plug in for. Not mandatory, but it's another point that we can use. Based off of the graph, we see pretty much everything we've denoted. We see that there's a 0 at 0. When x is 1, the outcome's 1. When x is 2, there's a 0. The end behavior's on point. And we've seen a lot of characteristics, and it's all based off of the properties we've seen in this section. So if you're still unsure about some of these properties, let me know. Check the textbook, ask a question, shoot me an email. Thanks for watching.